Hello, welcome to this webinar brought to you by the Asia Society Policy Institute's Center for China Analysis. It is the third episode in this series where we delve into the intricate intersections of technology, geopolitics, and global affairs in the realm of AI. Today, we're navigating the complex landscape of military AI, US-China AI competition, Huawei's recent 5G breakthroughs, the effectiveness of US export controls, et cetera, et cetera. And we'll be talking about how to build a balanced framework in the world of AI regulation. I'm your host, Lizzie, and joining me are two amazing expert guests. First up, we have the distinguished Paul Shar. Paul Shar is the Executive Vice President and Director of Studies at CNAS. Paul Shar is the award-winning author of Four Battlegrounds, Power in the Age of Artificial Intelligence. Paul, it's fantastic to have you here.
Thank you. Thanks for having me.
And joining us alongside Paul Shar is the equally distinguished Paul Triolo. Paul Triolo is a senior associate with the trustee chair in Chinese business and economics at the Center for Strategic and International Studies. Paul's views and writings are frequently quoted in international media outlets. Paul, thank you so much for being here with me.
Great to be here.
Now, as you might have noticed, we have two Pauls with us. So to keep things friendly and clear, we will refer to them as Paul S and Paul T throughout our discussion. So with that bit of housekeeping out of the way, let's jump right into our conversation. I should mention to our audience that you are free to use the webinar chat function to raise questions. We will leave 15 minutes at the very end of the webinar to address your questions. If your question is posed to a specific expert, please make that clear in the question. So for the first part of our discussion, we're going to turn to military AI and diplomacy. And here I'm going to turn to Paul S. Many of our audience will remember the recent diplomatic discussions between President Biden and President Xi concerning the responsible use of AI military applications. So Paul S., can you just give us some insights into how AI technologies are currently utilized in military applications and why their integration is considered a game changer in modern warfare?
Well, thanks so much, and very excited for the discussion today. There were certainly some tantalizing hints prior to the Biden-Xi meeting about a potential agreement between the U.S. and China on guardrails on military use of AI. We ended up not coming to fruition as part of the dialogue, but the U.S. and China are talking, which is really important because this is an urgent area that needs more attention. And certainly, both the United States and China are working hard to adopt AI into their militaries, as are other countries and non-state groups around the world. AI technology is pretty widely available. And so we already see, for example, the use of image classifiers that are based on machine learning, that can use machine learning to identify images and objects in video feeds being used in drones in Ukraine. So you don't need to necessarily be one of the world's most advanced militaries or a leader in AI to use AI technology in the military. But there's some tremendous opportunities to do so, to process information faster, to make better and faster decisions. And there's a lot of value in the U.S. and China looking for ways to manage some of that competition because there are risks in using AI systems that are unreliable and risking potential accidents or escalation, and making sure that we don't see countries engage in a race to the bottom on safety, where they're deploying military AI systems before they're safe.
Fantastic. So Paul, as moving on to China's military AI development, can you give us a concise overview of the current state of development, the potential challenges, as well as the implication for global security?
Yeah, so China is very keen to use AI to improve its military. We see them doing experiments like large drone swarm demonstrations, doing experiments using AI fighter pilots. Oftentimes, if the U.S. military does a major demonstration, we'll see China follow suit not very long after. And in Chinese writings, they talk about the importance of intelligentizing warfare, about using AI and other digital technologies, computer networks, big data, cloud computing to help process information faster. I think China, like other militaries, are trying to figure out what do you do with these technologies to use them most effectively. And that's one of the things that stands out in the history of warfare is that oftentimes new technologies proliferate pretty quickly, but what matters most is figuring out how do you use this most effectively. And that pattern of innovation is probably going to be one of the decisive factors in which militaries are going to stay ahead.
Fantastic. And in the realm of military AI, are there channels, or what are the channels for the United States and China to establish international norms and agreements that both sides can commit to? We know military-to-military communication had been on hold for quite a while before the discussion between President Biden and President Xi.
Well, certainly direct bilateral communication is really key, so it's encouraging to see progress in that domain, and hopefully AI is an important area of conversation. But there are also international forums. There's obviously a tremendous amount of international discussions going on underway about AI more broadly. The Bletchley Park Declaration at the UK summit very recently that both the US and China signed. China had rolled out their own global AI governance initiative. But on AI military use in particular, there was the Responsible AI in the Military Summit, the REAIM Summit, just last year, and there's another one coming up. So that's another opportunity for both nations to then shape global norms and expectations, either independently or ideally together, about how AI should be used in the military.
Fantastic. Thank you so much, Paul S., for your insights. Shifting our focus a little bit, we're going to turn to the second part of our discussion where we talk about the relative strength in AI between U.S. and China. There are recent media reports suggesting that China and the U.S. are actually nearing parity in AI development. Paul T., I'm going to turn to your expertise here. While the U.S. leads in fundamental AI technology and research, China is actually rapidly implementing them in practical applications. So what factors drive this divergence in the style of U.S. development, and what are the potential implications?
Great question, Lizzie. And I'm not sure I would couch it quite like that. I think, companies in both countries have been deploying AI for a long time. In various types of applications. So I think it's important to just step back quickly and define what we mean by AI here. In 2017, I wrote an article with Kai-Fu Lee where we tried to look at China and the US and where they were in AI development. And we broke it down into several different categories. Internet sort of based AI, things like recommendation algorithms, business and enterprise focused AI, things like logistics and business operations. Perception AI, which is things like facial recognition, object recognition, and then autonomous AI, which is things like AI being used as part of autonomous vehicle systems, ADAS systems, for example. So in all those areas, we looked at which country was leading, which companies were leading, and China, of course, was very early on. Companies like Alibaba and Tencent were using AI algorithms in things like e-commerce. Transactions, and also in things like logistics. So Chinese companies were very, very early users of AI algorithms in very sort of, application-related processes. Perception AI, too. Chinese companies were leaders. Chinese researchers had done a lot of research and participated in international conferences on perception AI, things like natural language processing. And then on autonomous, we gave the U.S. a little bit of a lead here. So we tried to break it, get under the hood and get away from just, AI. I think if you look at sort of across the AI stack, you look at things like data, access to data, and then the sort of hardware area, that's a tricky one. Kai-Fu has said, talked about China leading in data. That's a complicated issue. But yes, they have a lot of data sets that may be unique. Each of the companies, for example, developing AI in China has access to big data sets. Baidu has 20 years of search history. Tencent has a lot of transactional data. Alibaba has a lot of e-commerce and logistics data. But I think the interesting thing is, as we get to the current situation, which is where the big focus is on generative AI and large language models, we're sort of in a little bit of a different world. And there, yes, arguably U.S. companies like OpenAI, Inflection, a lot of the sort of foundational leaders are leading in the sense of innovating and designing new approaches to generative AI. Transformers, for example, came out of the U.S. research community here. So in that sense, the U.S. research is leading, but Chinese companies are quickly coming up to speed on these areas in generative AI, both in terms of deployment of applications and in terms of sort of improving on existing models and developing their own models. There's something like 238 large language models now under development in China, which is a large number. And certainly companies like Baidu with ErnieBot that they just put out, it compares favorably, for example, in terms of performance with ChatGPT 3.5 and even ChatGPT 4. So the generative AI is sort of a new area where it comes out of the natural language processing and image processing. But it's still, the use cases and the sort of applications are still under development. And so trying to assess who's leading in that is a bit of a challenge. On the hardware side, though, I think obviously the U.S. and U.S. companies in terms of developing advanced GPUs are far ahead of the game. And we'll talk more about that when we get to the export control piece of it and why that's such an obsession of the U.S. government in terms of controlling Chinese company access to GPUs. But clearly, Chinese companies have been trying to catch up in the hardware development space, but that's really challenging. NVIDIA and AMD and Intel, for example, have big leads there. And particularly in things like software development environments around AI, which is a critical part of the AI stack. Chinese companies are lagging, and most developers use PyTorch and TensorFlow that come out of Facebook and Google, for example. And so it depends on what you're talking about, what part of the AI stack, and how quickly the Chinese companies have been able to sort of come up the learning curve. So when you talk about who's leading in AI, you have to be very careful, I think, and quickly get under the hood and look at some of the individual applications and processes. But definitely the general consensus in 2017, when I wrote that first paper, is that U.S. companies tend to be leaders in sort of basic research and innovation in the space. But I think that's a general comment, but I think that's changing fast. Chinese researchers are very good in these areas, and then of course in terms of application using AI across the board, Chinese companies have been very out in front on all this. And generative AI finally is the area where it's hard to say who's leading, and that's just something that will unfold over the next couple of years in terms of actual applications.
Fantastic. And we'll be talking about sort of China's strategy to catch up, so to speak, on hardware and other fronts. But before that, Paul T, can you also shed light on some of the key industrial or commercial applications of AI technology that China is currently prioritizing? I mean, I've heard a lot of talking about AI diagnosis. I've heard AI-powered, sort of automatic, driving, et cetera, et cetera. So what are those key areas of commercial applications that you can see in China, and where investors are now focusing in terms of China's AI landscape?
Yeah, great question. And, again, going back a little bit, this has been an evolving sort of situation in China. The first wave of AI applications did tend to be in things like e-commerce. And in the facial recognition area, of course, public security in China was interested in robust facial recognition systems. And so a lot of investment and money went into those companies. But I think now we're sort of in a different wave here where we're looking at companies actually need to make money now, and also to figure out applications that will drive revenue. So yes, one of the areas I would say is medical diagnosis, and that's been again sort of in around for a long time. But Chinese companies have been particularly good in this regard. So just this week, for example, there was an interesting paper released in Archive that talked about an AI application for detecting pancreatic cancer, and it's interesting sort of data point here. It was written by a whole range of authors including from Chinese sort of medical researchers, and Alibaba's Damo Academy was one of the lead authors. But there were participants from Harvard, Johns Hopkins, and a university in Prague. So that shows that, particularly in that kind of application, medical diagnosis, it's a very global and cooperative field where AI researchers in the US and China and other countries are all collaborating. There's other really good companies like InfraVision, which is another company, Chinese company, started by two Chinese grad students who went to university in the U.S. They then went back to China and trained their AI algorithm for detecting cancer in China, working closely with hospitals. And then they're deploying that algorithm in the U.S., hiring engineers in the U.S., and they have a presence in Europe and the U.K. And then the rest of the Asia Pacific. So in that case, it's a good example of a Chinese AI company that is able to go global because there are maybe less sensitivities around things like medical diagnosis of tumors and other things, right? So that there's some good examples of Chinese companies in that. The other area is ADAS systems, as I mentioned earlier. So a lot of Chinese companies, of course, are really advanced in deploying AI applications in autonomous vehicles. So if you look at a company like Pony AI, for example, they have a level 4 capability. I'd ridden in one of their vehicles in Beijing with no driver in the front seat, navigating a complicated suburb of Beijing, and it was quite good. It was way better than the Tesla that I drive, which is only level 2 plus. But it really felt like the car was in control the whole time. So Chinese companies, including Huawei and of course Pony and WeRide, a bunch of other ones, are really doing quite advanced work in AI algorithms applied to autonomous driving. And then finally, with generative AI, you see companies like Huawei doing things like port automation. So if you go to this demonstration port in Tianjin, there's no workers there. Everything is being done remotely by a couple of people. And it's all automated, and it uses a combination of AI and other techniques. 5G is of course, an important part of that. And then there are applications in mining. So Huawei is using its Pangu large language model, for example, in as part of automation of mining operations. There's a big mining operation in Shandong that's all automated using a combination of, again, generative AI and 5G. So there's, those are the kinds of applications that are a huge focus in China right now.
Fantastic. Thank you so much. Since you already mentioned Huawei, so let's turn to Huawei next. And we'll be talking more generally about China's quest for domestic AI hardware and chips. So turning our attention to Huawei, we know the company has faced challenges amid U.S. sanctions, et cetera, et cetera. And despite this, they've managed to re-enter the 5G phone market. Here, I'd really love to hear from both of you, starting with Paul S. So Paul S., can you sort of detail the strategies employed by Huawei and what are the lessons to be learned from Huawei's breakthrough?
Well, they're certainly going to make do with the technology that they have on hand and see as far as they can take that in terms of building more advanced chips. I think what remains to be seen is how far they're going to be able to take that. And I think we'll see they've certainly been able to develop some more capable chips. I think the biggest question is going to be, can they scale that in a way that's cost effective? And one of the big unknowns here is U.S. export controls is then pushing Chinese companies to maybe use the technology in novel ways or simply invest in new types of technology for leading edge nodes or to circumvent those means of production and find potentially new different kinds of breakthroughs. In the short term, they're going to have significant challenges going forward. It's clear that the export controls are going to be able to slow down some development and put some roadblocks in their way. I think in the long term, there's some very open questions, and it's going to be very challenging for the U.S. controls to actually hold back Chinese chip development over time.
Fantastic. So, Paul T., please also chime in here. How do you assess Huawei's current state of development in terms of its chip technology? What are the lessons we should learn from Huawei's surprising breakthrough?
Well, you have to put the breakthrough in some context. I got a hold of a Mate 60 in Shanghai a couple of weeks ago. It's a very impressive device. So again, it's important to note that there are the two real big strands coming together here. One is the export controls on Huawei itself, and the extension of extraterritorial export controls on Huawei that prevents it from using TSMC, for example, to manufacture those advanced chips. And the other strand of export controls, which is newer, coming from last October 7th, is our controls on SMIC, the domestic foundry that actually manufactured this chip, probably at the 7-nanometer node, although both companies are being pretty mum about the origin of this chip. But basically what happened was HiSilicon, which is the chip design arm of Huawei, was designing at a very advanced level before the U.S. put controls on Huawei in 2020. And so HiSilicon was designing at 5 and 3 nanometers. And so what Huawei's been able to do is turn that HiSilicon design around and use it with SMIC's capacity to do some layers at 7 nanometers using their existing tools. Now, those tools that SMIC used, they've had since 2019. The actual techniques for manufacturing advanced semiconductors at that level using those tools that SMIC has are well known in the industry. So even before the October 7th controls, SMIC and Huawei had everything they needed to actually manufacture that chip. Now, the challenge is manufacturing that chip at commercial yields and scale. So there's still a lot of questions about, as Paul noted, about whether SMIC can ramp up and manufacture the tens of millions of systems on a chip that you need if you're going to be sort of competitive in the smartphone business. This is a very different business model, for example, than say 5G base stations. And so there's still some question about whether how quickly and rapidly SMIC can ramp up to produce the numbers of systems on a chip that Huawei will need, and then where they go. What's the roadmap going forward? There's still a lot of concerns about that. Currently, the thinking is you can take the equipment that SMIC already has, the advanced DUV lithography equipment, for example, probably can go to some level of like 5 nanometers. It's capable of doing that, but it's just really challenging to do that and get the yields you need to sort of produce the again sort of tens of millions of chips. Before the export controls, for example, Huawei was producing 250 million chips, the Kirin 9000 series at TSMC. So that's the kind of scale you need to be able to sort of produce generation after generation of chips. Now, one thing we should just quickly mention too is that the U.S. export controls, one effect of them has been to force Chinese tool makers to get better, to sort of be more innovative. And so what we've seen, for example, is the sort of vertical integration of Chinese chip tool makers working very, very closely with the foundries in China, like SMIC and Qualcomm, which is another key player. So when you try to determine how effective the export controls are, of course, they're effective in cutting off some access to technology, but Chinese companies have been pretty effective in working around that, as we see from the Mot 60. And also Huawei used a lot of very interesting engineering techniques to try to mitigate some of the deficiencies of having to use the less advanced node. So, for example, things like power consumption, they managed to do some novel things to improve performance there. And they've included in the Mot 60 some 6G, 5.5 or 6G capabilities like satellite communications, satellite messaging, and satellite phone calls. So they're really pushing the envelope in terms of engineering, using their existing tools and using the existing capabilities that Chinese companies have. So it's a pretty impressive feat, regardless of what you think of the export controls.
Thank you so much. So, we talk about Huawei and SMIC, but what's sort of the general status of China's domestic chip development, especially compared with global leaders? I want to hear sort of a evaluation from both of you. And, besides Huawei and SMIC, as we mentioned, who are the prominent players in this place that we should be, on the watch out for? Please, starting with Paul S.
Sure. So I think, China's indigenous chip making capacity has lagged behind the industry for a very long time. It's an area that they've struggled to develop despite a tremendous amount of government investment in this space. Now, of course, the export controls change that dramatically in two key ways. One is that the U.S. controls, along with Japan and the Netherlands, on chip-making equipment, make it even harder for foundries like SMIC to be making chips because they're cutting off their access to the most advanced technology, things like extreme ultraviolet lithography and associated other tools and equipment. However, what the U.S. export controls also do is create enormous market incentives for Chinese chip makers and equipment providers to then find ways to innovate, because the U.S. controls, the extraterritorial controls on the chips themselves, now create this huge market for advanced chips inside China, the kind of chips that Paul was talking about that Huawei was making. Now they're denied access to from TSMC, from their advanced nodes. And so there's now big advantages inside China for finding ways to maybe be more creative, using deep ultraviolet lithography, seeing how far can you go there. I think very much an open question. But we've also seen that not just in China, but globally, there's been this huge explosion of companies in the design space. So while there's been a concentration of companies on the foundry space, at each node, there's fewer and fewer companies, making the most advanced chips, manufacturing them. In the design space, there's lots of companies designing chips, and a lot of Chinese companies are doing innovative things in the design space, and that's a room for them to continue to grow. Kind of to some extent bottlenecked within the nodes that they're going to have access to on the manufacturing side, but continue to innovate and design. And so I think, we're going to see how far China can push that, but there's big incentives for them to do so to try to meet that market.
Thank you so much. And turning to Paul T, how would you assess China's current state of development in terms of?
Yeah, that's a great question, Lizzie. And I've actually got a paper in draft that's looking at sort of where China is overall in the semiconductor industry. So just a quick highlight. I agree with Paul on the design side. Chinese companies are very advanced. HiSilicon was designing chips, that were comparable to Qualcomm and other leading companies in the sort of smartphone space. And you've got other companies like Unisoc and Xiaomi. A lot of the phone companies have tried to get into design. It's a really tricky thing to get into, though, because it's a big commitment financially if you're going to really get into advanced semiconductor design. But you also have companies in the GPU space like BREN and More Threads that were also added to the entity list around October 17th. But the big players in China like Alibaba and ByteDance are also designing their own chips. And so, there's a lot of players in that space. Horizon Robotics, for example, is another key player designing edge AI semiconductors and is doing quite well. The problem, as Paul notes, is fabbing this stuff. And how do you fab this stuff when in some cases you're cut off from doing advanced designs at TSMC? If you're a Chinese company that's on the FDPR entity list, for example, which will prevent you from using TSMC. So a lot of these companies are on those lists. So in China, you have SMIC, and you have four really major fabs. You have SMIC, Huahong, and then for memory, you have Yangtze Memory, YMTC, and CXMT. And each one of those is under some sort of U.S. sanction and is trying to figure out a way around this by working with the tool makers. CXMT today just announced a breakthrough in DRAM, for example. But again, if you look at that, it's basically 2020 technology or 2018, 2019 technology. So a lot of the efforts in the fab space are Chinese companies catching up to basically 2 or 3 or 4 years ago of where the Western leaders were. So the challenge going forward is how do they keep moving up the value chain? So as I noted, the Chinese tool makers, and this is companies like Naura and AMEC and SMEE. These are companies that are competing with Western tool makers like Applied Materials, Lam and KLA Tencor for metrology. And so all those companies in China now have, as Paul noted, have this incentive to get better, move up the supply chain, but also work much more closely with the foundries, because that's really how Western tool makers work. All the U.S. tool makers, for example, work very closely with TSMC, and that's how you get better. You work with the design companies designing advanced designs. Then the tool makers have to make better tools, and the companies that are fabbing those chips have to figure out processes that can use those tools and be used for manufacturing advanced designs. So all that is happening within China, but it's a big challenge because as Paul noted, the export controls mean that those foundries can't get access to EUV lithography, for example, which is what many of the other foundries are using, Intel, TSMC, and Samsung. And so they have to figure out a way around that. Now, there's lots of other things that the Chinese government and the Chinese companies are trying to do to figure out alternative approaches to things like advanced lithography. Because really, in this space, these technologies, it's not like that U.S. companies or Japanese or Netherlands companies have technology that's locked in a box, and then if you prevent China from getting it, China can't do it. These are applied science. This is applied science, and so there's many different ways to do these things. For example, with the tool makers, and so Chinese companies, and with help from the Chinese government, are trying to figure out ways to do things differently and do things better, and trying to get to some point where they can get back in the game of manufacturing advanced semiconductors. Probably next year they'll have a 28 nanometer line that's all domestic tools, probably still with ASML lithography as part of that, and then they'll move to 14 nanometers and have a fully qualified domestic production line without any largely free of Western tools, except for probably in lithography. So there's a lot of efforts underway in China to do that, and the Chinese government has revamped its whole approach to semiconductor industry policy, and is going to be driving some really innovative efforts in that sector. For example, to share government R&D with a select group of Chinese commercial companies to try to push and get around and sort of advance despite some of the U.S. export controls. So this process is going to play out over the next 2 to 3 years as Chinese companies like SMIC extend the capabilities of their existing tools and try to figure out where to go from there.
Fantastic. And in the next section, we're going to turn to policy. We're going to discuss sort of the effectiveness of the United States policy of export controls and sanctions, and the Chinese policy of semiconductor industrial policy is big fun, so to speak, as Paul just mentioned. So I'm going to turn to Paul S. first. As you know, the Biden administration recently expanded its set of restrictions on exports of advanced computing chips to China. Do you see these new sets of rules as likely to be more effective in achieving the administration's intended goals?
Well, to some extent, we know that they are, just because they capture now a wider set of chips. And one of the things that we've seen is when the export controls first came out last year, NVIDIA, of course, adjusted their chip designs to fall under the threshold. U.S. now moving that sort of yardstick in terms of what's permitted. And it's clear that the U.S. government is going to continue to be adaptive to what we're seeing U.S. companies do, as well as Chinese companies and others, to try to cut off ways of China getting access to either chips or chip-making equipment. But it's going to be a moving target. And whether it's ultimately effective in restraining Chinese chip development and AI development is, I think, really challenging, not the least of which because when it comes to AI, there's actually lots of ways to get access to the computing hardware that you need. Chips themselves are one way to do that. But another way is through cloud computing providers. And the export controls, go after that as well, expanding the scope, looking at data centers of Chinese companies outside of China. The executive order that the White House recently released begins to make moves on know your customer requirements for U.S. cloud providers. And so those are some steps the U.S. is trying to take that I think are going to be needed ultimately if the U.S. is going to have to try to find ways to be restricting Chinese companies' access to cloud compute. Actually, the cloud is a better approach for the U.S. to take that can be a little more fine-grained in terms of its approach. The U.S. has talked about concern about Chinese military use, human rights abuses inside China, and certainly with the recent export controls, a lot of concern about what the executive order talks about as dual-use foundation models, so the most capable advanced AI models. And if you can control through the cloud, that actually can allow more fine-grained controls, which could undercut some of these market incentives that exist that we've been talking about that are driving Chinese chip development internally. So there could be a better approach over time. And then the last component that really remains completely unaddressed in all of this is open source AI models, which is to say that right now in the current setup, you have large U.S. companies training cutting-edge AI models and then releasing them open source, which entirely circumvents U.S. export controls. So even if the U.S. Is successful in restricting China's access to chips themselves, that doesn't matter if Chinese labs can go download an open source model and then fine tune it at very, very low cost. You don't necessarily need the most advanced chips to do that. And so I think we're going to continue to see the U.S. government be responsive to changes in the marketplace and in the technology, but it is a moving target, and there's still a lot of gaps in U.S. export controls.
Fantastic. And Paul T, please, your take on the effectiveness of the new set of export controls.
Yeah, great question, and agree with Paul's take on all this. I mean, I think the challenge here is, these controls were not really designed for some of the current purpose they're being put. I think we have to remember this. They were designed in an era of weapons of mass destruction, where you had sort of small companies that were producing a key widget that could be used, or key material that could be used in a nuclear weapon. They were not designed to maintain U.S. technology dominance or to prevent China from getting AI capability or high performance computing capability, or deal with human rights issues, right? So I think that's sort of the backdrop of all this. And so we see this challenge in sort of trying to draw lines around the technology that we saw with October 7th on the GPUs. NVIDIA right away came out with the CPU, GPUs that were just below the threshold, and we saw this again on October 17th. So that just highlights the challenge of using things like export controls for these purposes that they weren't designed to do. And also, in this age, you're trying to get on the tool making side, for example, it's a global issue. So you have companies in other countries that would need to align with the U.S. if you're going to have effective controls. And there, we at one point had the Wassenaar Agreement, which was a multilateral group, but Russia is part of that, so that's not sort of dysfunctional. And so you've had to have these other sort of workarounds with the U.S. and Japan and the Netherlands agreed to some collaboration on controls around semiconductor manufacturing equipment, but not on all controls. And so there's still a lot of disagreement. And the Dutch government and Japanese government, and the companies in those countries don't like some of the controls because China remains a huge market for them, and they're reluctant to fully align. So the challenge of the export controls sort of is it's a tool that sort of arguably needs to be revamped. So it's not surprising that there are ways that companies find ways around this, both on the U.S. side and on the China side. And then the other piece of it that I think is important is, what's the ultimate goal here? Is the goal to really prevent China from getting advanced computing capability? This was called out last year, for example, in what I've called the Sullivan Doctrine, where National Security Advisor Jake Sullivan talked about advanced compute and biotech and green tech as these force multipliers that are of key national security concern to the U.S. But advanced compute is a huge area, right? It includes semiconductor manufacturing equipment, AI, quantum computing, and high performance computing. And China already, for example, has a very robust high performance computing capacity. AI comes into play where there's some convergence of AI and high performance computing with the use of advanced GPUs, for example, to do acceleration for certain kinds of workloads in the HPC space. And that's one of the arguments for controlling these technologies, is that China could use high performance computing, it already does, to model weapon systems like hypersonic glide vehicles and missiles. And so that's an argument that the administration continually makes, that it's trying to control a small amount of technology that has military end use. The problem is that those GPUs the vast majority of them are used for non-military applications in China. They're used for drug discovery or as we talked about, cancer detection or materials development. So the vast majority are not used for military end use. And so the administration is controlling, in a sense, this sort of very, very dual use technology in ways that have a major impact on China. So, for example, already after the October 17th controls, Alibaba and Tencent said this would have a big impact on their cloud services, right? These are companies that don't provide anything to the military, arguably, or very little to the military. And they're commercial companies. They're e-commerce companies and social media and gaming companies. But the impact of those October 7th controls is hitting them because they can't have a reliable long-term source of GPUs to offer services in the cloud or to design generative AI models. Most companies in China have stockpiled about 2 years worth of those advanced GPUs, and it'll probably be okay for 2 years. But then after that, the question becomes, what happens? What other workarounds are they going to be able to find to continue to have access to reliable, advanced hardware? So again, the question of sort of how effective the controls are, it depends on, what one believes is the end goal of this, and whether this is a realistic to believe that the U.S. government can control China's ability to develop high performance computing and advanced computing and AI by controlling so-called choke point technologies like GPUs. And I think the jury is still out on that because the technology is very complicated and changes rapidly. And these controls there are ways to circumvent these controls. But the longer term issue is AI, whether AI and how important that will be for national security and things like cybersecurity, and enabling malicious actors to develop bioweapons using generative AI models. And that's the fear, I think, in the U.S. government, in the EO that Paul mentioned, on AI EO, there was a big focus on national security related issues around AI. And then the sort of general fear that over the long term, artificial general intelligence, whoever gets there first, will have a big advantage, both from a sort of national security and economic security point of view. But that's a far-flung sort of concern to be implementing controls now. And again, that highlights my initial point that these controls were not designed to prevent the future development of artificial general intelligence by some malicious actor or by a country. So it's a very challenging prospect. And in the short term, the big losers are arguably, in this case, U.S. companies. Whether it's the tool makers on the manufacturing side or the tech companies like NVIDIA, Intel, Qualcomm on the sort of the chip sales side. So it's a challenging issue to determine are these effective and sort of who's winning.
I see. So, Paul, since you mentioned, I just wanted to talk a little bit about the misalignment of incentives, so to speak, here. Are other countries on board, or to what extent are other countries like the Netherlands and Japan and Korea on board with the United States set of export controls and sanctions? And how are industry leaders, to whom China is still a vast market, navigating this new regulatory landscape? How are they thinking about those export control measures? I'm going to start with Paul S., please.
Sure. So on the export controls on the manufacturing equipment, I mean, U.S. has been dragging Japan and Netherlands along reluctantly, as Paul mentioned. There are some disagreements between the allies on what specific kinds of where to draw the line on some of these controls, and there's a lot of money at stake for these companies in, frankly, all three of the countries, including U.S. companies. Well, it's a little bit different with U.S. companies, where U.S. companies, of course, have, depending on the company, many of them have huge incentives to be supplying technology, whether it's chip making tools to get that they can with export controls, or chips themselves, as we see the case of NVIDIA, to the Chinese market. And U.S. companies are going to find ways to continue to supply to the Chinese market to the extent that they can, and it's permissible by the U.S. government. And now I think, the latest development on the chip export controls, for example, where when they first came out, there's a certain threshold by the U.S. government. NVIDIA redesigned their chips, released ones just under the threshold. Now we've seen the U.S. government move that even further. I just want to point out, it's not necessarily a bad thing if U.S. companies are saying, okay, we're going to go ahead and ship whatever the technology is just below the threshold that the U.S. government sets. If you set the threshold in the right place, that's fine. What that may highlight is if then the U.S. looks at that and the government says, well, actually, we're not happy about that. Maybe we set the threshold in the wrong place. Mm-hmm. And we need to see some adjustments there. But ultimately, like the big picture here, and Paul was talking about sort of this wide, expansive set of these export controls, is in the U.S. government's interest for these controls to be as narrowly scoped as possible for whatever goal they're trying to accomplish. And it's been a little bit uncertain exactly what is the goal the U.S. government has here. Jake Sullivan's given a number of speeches talking about, and last fall, when the export controls first rolled out, talking about the shifting the U.S. goal to keep China as far behind as possible in these technologies. But specifically with regard to the chips, the U.S. government's talked about kind of these very narrow military-specific applications, WMD, hypersonic missiles. Okay, is that what they're going after? Is it to create some distance between Chinese labs and U.S. labs on the most cutting-edge models, which are now we're seeing very much dual use, and they have a lot of commercial applications, but also potentially applications in enabling the development of chemical and biological weapons, in cyber tools, in basic scientific discovery. I think there's a lot of unknowns there, but we can already start to see with GPT-4 some kind of hints at some of those capabilities in potentially future models that may not be too far down the road. So is that the goal? Or is it just across the board to try to hold China back And right now, the export controls are so broad that they're affecting things like commercial cloud applications that are not only not militarily relevant, it's just hard to see the strategic significance to the U.S., even as sort of like a basic foundational science and technology advantage here. And so, the extent that the U.S. can find ways to more narrowly scope these controls, obviously we want them to be multilateral with allies, but to make them as targeted as possible, it's going to be in U.S. interest in the long run to make sure they do that.
Fantastic. Thank you so much. Paul T, please also weigh in here.
Yeah, just real quickly on Japan and the Netherlands. This is a complicated issue because neither of those countries has, for example, the type of end-use controls or domestic person controls that were included in the U.S. package on October 7th. And so that has complicated the issue of getting some level of collaboration. And companies in those countries like ASML, for example, in the Netherlands are really, they're a huge company. They're sort of the Google and the Intel all rolled into one of the Netherlands. And so the Netherlands, the Dutch government has not been eager, for example, to go along with all the U.S. controls. On October 17th, for example, the U.S. added a technology parameter called dedicated chuck overlay, which is a DCO, which is a really complicated term, but it refers to how you get accuracy, for example, in DUV lithography systems. And that meant that the Dutch now have to control much older gear, so gear that's more than 10 years old, that could be used by some end user in China, for example, to try to get around some of the limitations on the end use controls that the U.S. has imposed. And the ASML, of course, is livid about this because they don't. This is not cutting edge technology in their view, and they have a lot of equipment in China that falls under these categories. And so both the Japanese government and the Dutch government, for example, are really not eager to align fully on these controls because their companies are going to be the ones impacted. In the case of Japan, Tel and Canon and Nikon, for example, are all producing equipment, and China is a huge market. Those countries are also concerned about Chinese retaliation, which we haven't talked about, and there's a growing concern that China will retaliate against some of these controls. So this week, for example, I think tomorrow or Friday, Chinese controls are on graphite. Will go into effect. And the graphite controls they put into effect were a direct response to the October 17th controls. So China has not yet pulled the trigger, for example, on some of these restrictions they put in place on gallium and germanium last summer in response to U.S. export controls, and in October around graphite. But that's the concern that companies in countries that are aligning with the U.S., for example, on some of these export controls could be impacted by Chinese retaliation. So as Paul rightly knows, I think the argument in the Netherlands and Japan is that these controls should be very, very narrow. And before October 7th, there was some understanding about how narrow the controls should be amongst some of those allies. And then when the October 7th controls were released, they turned out to have been expanded considerably, for example, around some of the end-use controls that surprised U.S. allies. And so that the last year has been, in part, very detailed negotiation around trying to get and arm-twisting allies to align with those more expanded controls. And so getting back to Paul's other great points, Jake Sullivan has talked about a small yard, high fence. But if you look at the U.S. policy and other aspects of what Jake Sullivan has said, for example, around advanced compute, the yard is pretty big, and the fence, is sort of growing, but because of these technologies have global supply chains, the yard is necessarily large because you do have other countries and companies involved in this. And so that's been part of the challenge is that the discussion has been around that this is a narrow approach, but in reality, it's been a much broader approach. And that has impacted a lot of companies in the supply chain and the semiconductor supply chain, and arguably a lot of U.S. technology leaders whose argument is that access to the China market is important for them to continue to do R&D and maintain their leadership position in these advanced technologies, and that's a national security issue. That argument hasn't gotten a lot of traction in Washington, but that's what how the industry views the controls, sort of verging away from a very, very narrow focus on a smaller set of advanced technologies.
Fantastic. Let's turn to the other side of the coin, so to speak. How would you assess the likely success versus the failure of China's industrial policy when it comes to semiconductor, big fund version 2, etc.? Starting with Paul S., please.
Well, certainly we've seen that China's been willing to invest tremendous amounts of money in not just chips, but other areas in terms of industrial policy with mixed success. And in some areas, they've had significant progress. Chip making has been a long struggle. I think, big picture, a lot of these efforts, they're very inefficient. They're very wasteful, but the government has been willing to spend tremendous amounts of money, and they've been able to make progress in a number of significant areas. Now, again, one of the biggest challenges here with chips is it's not just money in the past. Money has not been enough to get there. But what's different now is that there are these market incentives for Chinese tool makers, chip makers to be meeting this demand. And, that creates these feedback loops where you've now got, as Paul was talking about earlier in our session here, tool makers working closely with the chip makers, getting that kind of feedback and getting products out into the marketplace, engaging with users, whether it's other companies or commercial users, and getting that feedback on performance is going to help to level up quickly. And certainly that's a very different kind of role that the government plays than we see here in the United States. We've seen some movement, of course, recently in the U.S. in terms of the U.S. government taking a bigger role in science technology innovation with the CHIPS Act and significant amount of funding towards U.S. chip making here, R&D, and more advanced foundries here in the U.S. But in general, still the U.S. government's been just much more reluctant to be engaged, for better or worse. Obviously, government spending can be much more inefficient than the private market, but there are lots of ways where government investment in basic R&D might be doing things that private companies aren't willing to do on their own.
Yes, turning to Paul T.
Yeah, I think, and again, I'm writing a fairly detailed paper on this, on China's sort of reaction to all this. But I think there's a couple of things just to highlight that are new. So there's going to be more of a top-down leadership in China when it comes to semiconductors. There's a new leading small group at the very top that's going to be overseeing this. Basically, the Chinese have gone from allowing sort of the scientific community to drive things. This is back in the 863 program days, where there was a much heavier government role. Then, with the setup of the National IC Investment Fund in 2014, the idea was to give market forces, more play. And the view now in China is that failed. And so there's a view now that China needs to figure out another approach to this. So potentially, for example, they may have a large state-owned enterprise that play a more prominent role in helping to drive the overall sector, because that's worked, for example, in the aerospace and other sectors where China has been successful in advancing the technology, and particularly domestically. And so I think that's going to be one thing. Then there's also going to be, as I noted earlier, more sharing of R&D with key private sector companies. So among those private sector companies are Huawei, SMIC, and Naura, that tool maker I mentioned. And that was announced earlier this year. And so there's going to be a lot more trying to leverage government R&D in these key choke point technologies, arguably, things like lithography, to try to help advance the sector. And then I think the new round of the National IC Fund was just funded recently, and it's going to focus on tool makers, because they now belatedly realize that a lot of the focus was on design and manufacturing, but it turns out that the tool making area has been the big Achilles heel, given, of course, the U.S. controls in place. And then I think there's also a lot of sort of R&D going on under the radar. Huawei, for example, has a tremendous amount of experience in all this manufacturing, all these manufacturing technologies, and I think they're working very closely with the tool makers and with companies like SMIC, obviously, on a whole range of new approaches. Huawei probably realizes it should have been more like Samsung, and is probably now pursuing that kind of a strategy where Samsung has its own foundry business, so they do all the commercial electronics, but they have a massive foundry business that manufactures most of their products. And I think Huawei probably regrets not pursuing that strategy earlier. And then I think the one other goal is to keep access to Chinese companies for critical things like materials and things like substrates and process gases, which haven't so far been the subject of export controls. So, for example, Japan and Taiwan and other places are critical sources of substrates and some of the things you actually need to do advanced manufacturing. And China's going to continue to try to keep access to those. And then I think finally that the Chinese Chinese companies are looking to poach more engineers and knowledge from companies in Japan and Korea and Taiwan, which is where a lot of that knowledge goes. Because really, at the end of the day, this industry is about knowledge and knowledge transfer, and so you need the people who know what they're doing to actually do this. The guy, for example, at SMIC who helped them move to the 7 nanometer process, was previously an executive at TSMC and Samsung, yes. And so those are the kind of people you need if China's going to make progress in these areas. But I think you have a whole of government effort here and a whole of industry effort to try to figure out the way forward here, and that's going to unfold over the next couple of years.
With that brilliant insight from both of you, we conclude the first part of our discussion